And good morning, third grade math students. It's time for some Eureka math. Now, Eureka in Latin means I have found it. And what have we found? We have found, by golly, the best way to learn math ever. Okay, we're going to start off with just a little bit of counting. Take your disc, and we're going to make 10 rows of 2. And kind of put them on your piece of paper off to the side here. Four rows of 2 and 5 rows of 2. And don't scrunch them together. Kind of leave some space here. 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. And it's okay if you can't see. You can imagine that there's 10 here. So we have a total of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. What we're going to do is we're going to take the second piece of paper and put it over that piece of paper. So we're going to say a multiplication sentence right here, and we're going to write it down. So we're going to write down 1 times 2 equals 2. Got it? Bet you guess what's going to be next. We're going to go down here, and we're going to say 2 times 2 equals 4. We'll scroll down. 2 times 3 equals 6. Oh, how about this one? Looks like it'd be 2 times 4 equals 1, 2, 3, 4, 5, 6, 7, 8. And I'll zoom out a little bit so we can all see this, but I think you're probably getting the idea. There we go. And up next would be 2 times 5. 1, 2, 3, 4, 5, which would equal 10. And we'll continue on down here. And it's 2 times 6 equals 12. 2 times 7 equals 14. 2 times 8 equals 16. 2 times 9 equals 18. And last but not least, oh, what happened? Oh, got caught down there. We could say 2 times 10 equals 20. And let's go ahead and count by 2s. 2, 4, and you count in your head. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Okay, that was our fluency practice. We're going to move on to our application problem. So you can put your disc or your squares aside. Don't think it's going to matter. Don't think you need them. Well, you might use them later on, so keep them handy. All right, our objective today, and I'm going to zoom back in so we can read this clearly along with me. There we go. Oops, a little too much. There we are. Okay, so our objective. We're going to demonstrate the commutativity, what a great word, commutativity of multiplication and practice related facts by skip counting objects in array models. Okay, but let's start off with our application problem. Anna picks 24 flowers. That's something we know. And she makes equal bundles of flowers and gives 1 bundle to each of her 7 friends. I'm going to circle 7. Uh-oh, she keeps a bundle for herself. I'm going to circle herself too. And we need to find out how many flowers does Anna put in each bundle. Well, let's think about that. Maybe we can make an array with using some dots. Oh, Mr. Leggett, do you think Anna bought me flowers? Well, Math Mutt, I don't know if you're a friend of Anna's. I'm sure if you're a friend that she bought you flowers. Well, I hope so, because I love the flowers. Well, that's very good, Math Mutt, but why don't you step aside and watch the problem so you can find out, and then maybe we'll find out if Anna bought you those flowers. Well, that's a very good idea. I love learning math, Mr. Leggett, especially Eureka math. Okay, well, I love teaching Eureka math, Mutt. So why don't you step aside now, and we'll figure out at the end of the lesson if Anna bought you the flowers, okay? Okay. All right. So let's figure this out. We have 24 flowers. we have 7 friends plus Anna, so that's 8. So we need 8 equal groups. Let's see what 8 equal groups would be. We'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that's 1, 2, 3, 4, 5, 6 friends. 19, 20, 21. And now we have 7 friends. So let's write that down. And we're going to write 7 friends. But look on our problem here. It says she keeps a bundle for herself. So right now we have 3, 6, 9, 12, 15, 18, 21. So Anna needs a bundle too. I wonder if the math mutt will get one. So we're going to put Anna right down here because she likes her flowers. And another way we could do this is with a model. How many total do we have now? Let's count them. 3, 6, 9, 12, 15, 18, 21, 24. So we're going to put a 24 over here, like so. And how many people got 3 flowers? Anna and her 7 friends. So that's a total of 8, right? So let's make 1, 2, 3, 4, 5, 6, 7, and 8. What goes in each of those circles? Well, it's 8 friends, or 7 friends in Anna, and they each got 3, so we could put 3, 3, 3, 3, 3, 3, 3, and 3. Count 3, 6, 9, 12, 15, 18, 21, 24. We could show this as a division sentence because we could take the total flowers. We had 24 flowers, right? And we divided them among Anna's 7 friends and Anna. So that's divided by 8. And of course, what would that equal? We've proved it. 3. Now we need to write because we've read, we've drawn, and now we write. Anna puts 3 flowers in each bundle. That's it, B there, just a little sloppy. And also note that every sentence starts with a capital and ends with a period. Every sentence that's written correctly, that's how it works. All right, we're going to move on, and you'll need another piece of white paper. Whoops. So we're going to put this aside. You can always pause it if you want to copy. And also, while you're at it, let's go ahead and put your name and date on the top. Today's date is actually tomorrow, will be the 27th, 19. All right, let's go on over to our concept development. We're moving pretty fast, I know, but that's just the way it is. And this is about rotating arrays 90 degrees. So 90 degrees. So we're going to start off like this, okay? And we're going to make an array. Let's not use our squares yet, okay? You know what? Let's go ahead and use them. We got them out, right? So let's go 1, 2, 3, 4, 5, 6, 7, 8. And we're going to label these 2, 4, 6, 8. And what we have here is 4 times 2 equals 8. So we have 4 rows of 2 to equal 8. 1, 2, 3, 4, 5, 6, 7, 8. Now let's rotate it 90 degrees. It's going to look like this. Look at this. Okay, hopefully you can see all that. So now we've changed things around a little bit. It looks like, looks like we have 2 rows of 4. So maybe that would be 2 times 4. Don't you think so? Let's do it again. We're going to go 4 times 2 equals 8, because we have 4 rows of 2, but then, and this we could say is 2 rows of 4. So it would be 2 times 4 equals 8. We're going to show that using dots now too, okay? Let's go ahead and do it. And we're going to call this one column, excuse me, we could get rid of our disk. I don't think we're going to be using them for a while. We'll call this A, and it goes just like this. 1, 2, 3, 4, 5, 6, 7, 8. That is 4 times 2 equals 8. 2 4 times. Now let's try method B. And this will be 2 times 4. You see the difference? But they have the same answer. This is called the commutative property. We can shift those numbers around and it'll be the same. Now we have 2 times 4, 2 groups of 4, or 4 times 2, 4 groups of 2 to get the same answer. Let's try another one before we move on. I'm going to flip this piece of paper and we're just going to show it like this. You know what? Let me get a fresh piece of paper without all this marking on it. So go ahead and get another piece of paper. And we're going to do 2 times 5. So let's do 2 times 5. So we can see that this is 2 times 5, right? 2 times 5. But what if we make it 5 times 2? So now we have 5 times 2. 2, 4, 6, 8, 10. They both equal the same amount. If it's 2 times 5 or, whoops, 5 times 2. They both equal 10. We're going to do one more with our disk. And let's move over to 3 times 4, okay? So we're going to 3 times of 4, okay? There's 1, 2, and 3. So now we have 3 times 4. How many does that equal? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or 4, 8, and 12. But what if we were to turn it around 90 degrees? We would get 4 times 3. So 4 rows of 3, it equals the same thing. It equals 12. And that, ladies and gentlemen, is your first lesson in the commutative property. We're going to have some more fun here. Let's take a look at our disks again. We're not going to make a row of 20. What we're going to do is 2, 4, and you can always pause this if you need to catch up, 6, 8, 10, 12, 14, and 16. So go ahead and make this array, and I'm going to zoom out so you can see it a little better. Or a lot better. There we have it. And I'm going to go ahead and number these. So we have 2, 4, 6, 8, 10, 12, 14, and 16. So what does the first factor, the 8 in your equation, represents? Well, that represents the number of equal groups in the array, the number of rows. Take a look at our rows. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to put an 8 right here. Now, if we think of 8 as the size of the groups, then how many groups does the array show? Each one of the groups is 2. 2 all the way down. So we could say 8 times 2 equals what? Well, we already got our answer down there, 16. But what if we wanted to turn it 90 degrees? Now we have 2 rows. So that's going to be my first factor number here, 2. And what are we going to multiply them by? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's 2 times 8 equals 16. So we could see that 8 times 2 equals the same as 2 times 8. Now, factors can trade meanings without always having to switch places in the equation. It's okay to write 8 times 2 equals 16 and think of 8 as the size of the group and 2 columns as the number of groups. In third grade, we'll usually write multiplication sentences, so that the first factor represents the number of groups. That makes them a little easier to read. But either factor can mean the size of the group or the number. So this way, we have 2 times 8, 2 groups of 8, and this way it is 8 groups of 2. Okay, we're going to start on, right now I'm probably still teaching the 4th graders, so what I'd like you to do is log on to Zern Math, and you have your Zern cards, so go ahead and log on to Zern. Thank you very much.